right, so for mobile security testing, we also need to know some basic reverse engineering concepts in order to understand the operating system, the architecture, as well as the programming language intricacies of mobile devices. Now, reverse engineering a mobile app is just basically an overview is the process of analyzing the compiled app to extract information about its source code to find out how it works. Okay, that's basic. But the goal of reverse engineering is comprehending the code here. Of course, you can do this by examining the compiled code, which we call static analysis, or observing the app during runtime, which is called dynamic analysis, or a combination of both. So Android offers reverse engineers big advantages that aren't necessarily available with iOS. And one of the reasons is because Android is open source. That means you can study its source code at Android Open Source Project and modify the OS and its standard tools any way you want. Sounds like fun. So in our setting up our laboratory section, we've built a reverse engineering environment with Android Debugging Bridge, ADB, APK Studio, APK Tool, and Bytecode Viewer. Now, Bytecode Viewer is a decompiler to make Java bytecode more, I'd say, readable by human beings. So we'll download an APK, decompile the DEX file, and analyze the source code with Bytecode Viewer and the APK tool. Now, throughout the course, we'll intentionally use vulnerable mobile applications that are created for security testing. And that's just to learn the insecurities of Android operating system. So I'll start with the insecure bank application, and we'll reverse engineer it. Are you ready? Let's get started. Open up the terminal screen. And here you just change the directory to desktop. So now let's unzip the APK file to a new folder and see the extracted files. All right, so we'll open the folder. And look, here we have some folders and files. Meta-INF folder. This contains the manifest information, as well as other metadata about the Java package. The res directory contains all the resources, such as images, icons, layout resources, etc. And here's the Android manifest file. So the classes.dex file contains code that's ultimately executed by Android runtime, and it references any classes or methods that are used within an app, as well as resources.arsc that is compiled binary form of resources. Now, let's decompile and analyze these files with Bytecode Viewer. Open Bytecode Viewer, add the APK of the insecure bank under the File menu. Open it up. Okay, so it's decompiling the APK now. And yeah, so here are the class files that are extracted from the DEX file. So let's click on one of them. So what you're looking at here are two panes in the workspace section here. Now the left pane shows the code with a JD GUI decompiler, and the right pane shows the code with the default Smalley decompiler. So under the View menu, you can change the pane options and select another decompiler if you want to use. So you can also add another pane. So let's change the second pane to bytecode. Open another class file. And yeah, so see how the second pane changes and shows us the code with a bytecode decompiler. Under the settings menu, you can change the default settings, of course. Now there's also a plugin system that will allow you to interact with the loaded class files. For example, you can write a malicious code searcher or anything else you can think of. You can either use one of the pre-written plugins or write your own. Down here in the lower left section, there's a search field to search for string methods and regex from all classes or the current class.